A sequence is a big math vocabulary word that means an ordered list of numbers, but along with the vocabulary is some crazy mathematical notation. Just try and confuse you. Don't let it though. Here's an example: 2, 4, 6, 8, 10. Can you list the next three terms in the sequence? Well, of course you can. It goes up by 2, so this would be 12, 14, and 16. Now let's look a little bit closer at this sequence. 2 is a first term. Mathematicians call this term a sub 1. 4 is a second term. Mathematicians call this term a sub 2. 6 is a third term called a sub 3, and so on. 2, 4, 6, 8, 10. A sub 1, A sub 2, A sub 3, A sub 4, A sub 5, ... A sub n. This last one is called the nth term of the sequence. When we ask you for the next three numbers of the sequence, we could have asked you what are the A sub 6, A sub 7, and A sub 8 terms. When we ask you for A sub n term, you must find the equation that would identify any term. It sounds hard, but it really is not. There are two kinds of sequences we will study. Arithmetic, think linear, constant rate of change. And geometric, think exponential, constant multiplier. Let's look at an example. So 2, 4, 6, 8, 10. Is there a constant rate of change? To test, you take the last one and subtract the one previous. So A sub 5 minus A sub 4. 10 minus 8 is 2. Then 8 minus 6 is 2. 6 minus 4 is 2. 4 minus 2 is 2. This clearly has a constant rate of change of 2. We call this a common difference. Therefore, this is linear. But in the world of sequences, we call this an arithmetic sequence. Let's try a different kind of sequence. 2, 4, 8, 16, 32, ... A sub n. If we test it for an arithmetic sequence, which would be 32 minus 16, we get 16. And then 16 minus 8, we get 8. So it is clearly not a constant rate of change. So it's not arithmetic. So now let's test it for the geometric. So we're going to start with A sub 5 divided by A sub 4. So 32 divided by 16 is 2. And then 16 divided by 8 is 2. 8 divided by 4 is 2. And 4 divided by 2 is 2. These are clearly going up by a factor of 2 each time. This is called a common ratio. To test if you have an arithmetic sequence, you're going to subtract the new from the old. To test if you have a geometric sequence, you're going to divide the new by the old. If both of these tests fail, you have neither. So let's take a look at problem number 1. So I can go and start with 64 minus 36. So 64 minus 36 is 28. And then I can take 36 minus 16, and that's 20. So it's clearly not going to be linear. So then what we can do is go 64 divided by 36. So 64 divided by 36, and that actually gives us a decimal. So the next thing we had tried was 64 divided by 36, and it gave us 1.7 repeating. And then if we try to do 36 divided by 16, 36 divided by 16, that gave us 2.25. So this is clearly not geometric either. So we would say this is neither. All right, let's take a look at problem 2. So what we can do, if we go up here and read what it says right here, arithmetic, subtract new by old. So your new one is 26 minus 29, that gives us negative 3. And then 29 minus 32, that's negative 3. And then 32 minus 35, that gives us negative 3. So this is arithmetic. That's it.